right, let's recall writing linear equations from word problems. We have Jared who prints t shirts. He charges $10 per shirt and has a one time setup fee of $30. The equation y is equal to 10x plus 30, where y is the cost and x is the number of t shirts, models the cost to order from him. What is variable and what is fixed? Now, this equation we know is a linear relation. How do we know that? We have y is equal to mx plus b. It follows the same pattern. We have a variable x, a coefficient, and we have a y-intercept of b. Our m, we remember, is our slope. Now, the slope can also be known as our rate. In this case, Jared is charging $10 per shirt. So our slope is also known as our rate, and the rate is known. But the difference is we have an x. X is our variable. And the reason this is variable is because depending on how many shirts you order from Jared, your cost is going to change. Our b is the 30 here. 30 in this equation is a one-time setup fee. This y-intercept is fixed. It doesn't change. No matter how many shirts you order, you still have to pay the $30 fee. And that doesn't change. So let's look at our equation of the linear relation again. Y is equal to mx plus b. The mx is the part that changes. It will vary depending on how many things are ordered and is multiplied with the rate. The y-intercept is fixed. It doesn't change. Now let's take a look at these examples. We need to write a linear equation and it says we need to define your variables. When you define your variables, we need to explain what x and y are representing. And we usually use a statement to say let x be and let y be. So let's start this one. A video store charges $20 membership fee and $2.50 for each video rented. Write an equation about the cost to the customer. Well, we know that the $20 is fixed. It doesn't matter whether the customer rents a video or not. To be a member, you need to pay $20. $2.50 is the rate. That's the rate per video. Now, what changes is the number of videos that the customer rents. So let's write a let statement. Let X be the number of videos rented. And we know that when we add them together, that will be the sum. So let Y and Y be the cost. So when I write my equation in the form of y is equal to mx plus b, I have y is equal to 2.5x plus 20. Let's do another example. A water tank originally contains 55 liters of water. More water is flowing in at 8 liters per minute. Write an equation to model the volume. Okay, we know that we have a starting point of 55 liters of water. Now, the starting point won't change. So we have a fixed value of 55 liters. Our rate now is 8 liters per minute. So the amount that goes into the container will really depend on how many minutes it's been flowing. So one of the hints is once you've identified the rate, your variable is always going to be related to the denominator of the rate. So we could say let x be the number of minutes water is flowing. Write an equation to model the volume. Okay, so our second one is and y be the volume of the container. Let's substitute that in. We have y is equal to 8 times x plus 55. All right, question 3. An attorney charges $250 for an initial meeting and $150 per hour for all hours worked after that. Write an equation to model client cost. Okay, what we have here is we know that the fixed rate or the fixed amount, $250. If you're meeting with the attorney, whether he or she does work for you, you are charged $250. The rate at which you are going to be charged is $150 per hour. So the rate will go up depending on the number of hours you use. Okay, let's look at the denominator or the word after per. $150 per hour. So our x, let x be the number of hours worked. And we have y, when we add these together, will be the cost to the client. Right? So we write our equation y is equal to mx plus b. M is our rate, 150x plus 250. Example 4. A printing company charges $20 flat rate for all orders and $2 per poster printed. Write an equation to model the cost. So we know that the fixed rate is $20. $20 will be our B. Our rate is $2 per poster. And this changes depending on the number of posters that are printed. So let's write our statement to define our variable. Let x be the number of posters printed. Then we have, and y is the cost. So our equation, y is equal to mx plus b. Right, two more examples. We have Sally earns $15 for each regular hour worked and $22 for each overtime hour. Write an equation to model her gross earnings. Now, right now, we have two things that can vary. She could be working regular hours, or she could be working overtime hours. So the two rates, we have regular hours, which would be $15 per hour, and we have overtime hours at $22.50 per hour. Now let's define this by using two different letters. We're going to say let X be the number of regular hours. Let Y be the number of overtime hours worked. And we can use the letter E to represent the earnings. So our equation in this case, we have E is equal to 15 times X plus 22.5Y. The equation has to come with a let statement that defines your variable. Otherwise, an equation like this is not very meaningful. Let's do another one similar to that. Tickets for the school show were sold. Adult tickets cost $5 and student tickets cost $2. Write an equation to model the revenue. So, how much money was earned from selling school show tickets? We have two different rates here. The first rate we have are adult tickets. Those are $5 per adult. We also have student tickets. Student tickets are $2 per student. So let's write an equation to model this. But before we write an equation, we need to define our variables. What's going to change is whether we're selling an adult ticket or whether we're selling a student ticket. So in my let statement, let R be revenue, but we also need to say let A be the number of adult tickets sold and S be the number of student tickets sold. So our revenue now is 5A plus 2S. Okay, I'm going to pause this, or please pause the video, work on these four questions, and we'll come back to take them up. All right, let's take this up. Our rate is 0.5 feet per day. And as a result, since it's per day, our variable is going to be X. And we have Y is the water level. Y is equal to 0.5x plus 34. For babysitting, Ibrahim charges $4 flat rate plus $9 per hour. Write an equation to model his rate. Okay, so rate $9 per hour. We're going to let X be the number of hours he babysat. Let Y be the cost, the total cost. We have Y is equal to 9x plus 4. A plumber charges $25 for a service call plus $50 of service, $50 per hour of service. Write an equation to model the cost. Let x be the number of hours and y be the total cost. We have y is equal to 50 times x plus 25. Last, Rufat collects aluminum cans to be recycled. He has 5 kilograms at the moment and collects an additional 3 kilograms each week. Write an equation to model the mass of aluminum cans. Okay, we know he's starting out with 5 kilograms. We know that the rate at which it increases is 3 kilograms per week. So let x be the number of weeks he has been collecting cans, and y be the mass of cans, so the total mass. Y is equal to 3 times x plus 5. Let's solve a problem using this. Andrew bakes and sells his goods at $10 per pie. Manira also bakes, but she has a base cost of $30 and then charges $5 per pie. Write a linear system to model the revenue. It should say the cost. So we know that for Andrew and for Manira, the rate that we're dealing with is the amount of money per pie. Let x be the number of pies sold, and y be the total cost. So for Andrew, we have y is equal to 10x. He doesn't have a base charge. For Manira, she has $5 per pie plus a base cost of 30. So let's graph this. For Andrew, the y-intercept is 0. So we're going to have 0, 0. And for each pie that he sells, we're going to increase by $10. Now, before I go on any further, I need to label my x and y axes. We have just said that x is the number of pies sold. Y is the cost. Okay, so we're rising by 10 and running by 1. Rise by 10, run by 1, rise, run. Okay, we can extend this line to here. So this is Andrew, y is equal to 10x. Manira now, I'm going to use red. Manira has a $30 base cost. And for each pie, she charges $5. So 5 over 1. I'm going to increase by 5, run by 1. Increase by 5, run by 1. 5 and 1, 5 and 1. 5 and 1. Right? We've got enough points to create a nice line. Manira, y is equal to 5x plus 30. Where do the lines intersect? The lines intersect at 6 and 60. So, what does the solution mean here? Well, we know the solution is equivalent to x and y. So, the x is the number of pies sold and the total cost. So, that means that both of them will cost exactly the same when they have sold. If somebody is buying 6 pies, the cost will be the same at $60. So the cost is $60 um, for both people when 6 pies are sold.